Hey, welcome back. Let's continue our talk about data structures. In the last episode, we talked about arrays, lists, and sets. And today we want to talk about maps, trees, and graphs. So, what is this all about? Well, a map you can think of as a kind of dictionary, as it's also sometimes called in some programming languages or data structure libraries. A map is like a dictionary. You can think of it like a phone book, right? You use a map to look up information quickly based on a specific key. For example, with a phone book, what's the key to look it up? Well, it's the name of the person that you want the telephone number of, right? So the key is the name of the person. The value that you're interested in is the actual phone number. Think of a dictionary of all the cities in an area, like in the United States. And the key would be the city name, and the value would be maybe the population of that particular city. A map consists of key value pairs. Each key is unique and can only happen once in the whole map. You use the key to access the corresponding value. And you can do that quite fast. A map is used to look up values quickly. Unlike arrays and lists, maps don't preserve the order of the values they contain, but it's not really important because the lookup is so quick that you don't really worry about the order. You use a map where you want to look up quickly a value for a specific key. So they are particularly efficient when it comes to searching, to inserting, or deleting items. You would like to use maps there. A tree is a hierarchical structure that has a root node at beginning and then branches and leaf nodes. It's like a family tree or an org chart in a company. It's used to represent a hierarchical relationship between different pieces of data, different pieces of information. For example, we could use a tree to represent the different levels of management in a company and which person reports to another person, what's the department structure there. This is what you could use a tree for. Or maybe the relationship between different categories of products on an e-commerce website. If you think of Amazon, you've got the homepage and the list of primary categories like books or clothing or electronics or whatever. And then when you select one of these main categories, you've got lots of subcategories and subcategories and subcategories. And you can think of these organization like a tree, right? You can store this information in a tree data structure. So trees are used to represent data in a hierarchical structure. They can be used to perform operations like searching, inserting, and deleting items. And in that, they are faster than arrays and lists when you are searching. But if you want to add and delete items, they are slower because sometimes they have to rebalance the tree, they have to reorganize the tree. Our third data structure type is a graph. And a graph you can use to represent relationships between different objects, like a social network. You've got different users there, and each user can be friends of another user. They can be part of different groups with different levels, access levels. You can be the administrator for one group and participate there, and you can write posts in that group. So that's another kind of data that you store in that graph because a certain post that you write in a group belongs to the group and is coming from you. So these are all kinds of different relationships between objects, between data, little pieces of data that you want to store. And for that, you can use graphs. So graphs are used to represent relationships between different objects. So, in summary, maps are used to look up information quickly based on a specific key. It's like a dictionary, right? You look up the key, you have the key and you look up the value for it. Trees are used to represent a relationship between different pieces of information, much like graphs, but with the trees, you have a hierarchical structure, right? You start with one specific master node and then you go through the branches and have different leaf nodes there. And graphs are also used to represent relationships, but in a more generic way, right? With the different nodes there having relationships to all kinds of other nodes.